Welcome back, everyone. In this video, we're going to go over the slope of a line. So fortunately, the slope of a line is a relatively intuitive concept in math. What we're measuring is the steepness of the line and attaching a number to it. And fortunately, the number that we get is bigger, the steeper the number is, and so forth, as you'll see. So taking a look at the four lines on your screen now, it should look like the one on the left is steeper than the one on the right. So the slopes, let me label these lines A, B, C, A. The slope of line A is going to end up being greater than the slope of line B. And out of all of these, the two that would have positive slopes will be A and B. There's only one that has negative slope, and that would be C. This is the one negative slope. A and B both have positive slope. As you look left to right, is it going up or is it going down? That's the slope. And that's convenient because a lot of languages are read left to right. So if you read left to right, if it's going up, you'll get a positive number for slope. If it's going down, you'll get a negative number for slope. D has a zero slope. Here it's a horizontal line and it has a zero slope. It's not going up or down. So the number that we'll come up with for slope will match our expectations in this way. Okay, the other thing that we should need to know about slope is that it shouldn't matter how far apart the 2 points are. So these two lines, let me call them L1 and L2 for line 1 and line 2, they should look like they're the same steepness. One is longer than the other, but they're the same steepness. And so the number that we get for slope is going to be the same for these two. So the slope, it turns out, is defined as a ratio, that is a division of the amount of change in the y direction divided by the amount of change in the x direction. And there's a formula for slope. And as input, we need 2 points. I'm labeling them in my drawing as x1, y1, and x2, y2. Here we're using subscripted variables because it makes our formulas easier to remember and process. If we labeled the points A, B, and C, D, then it's going to be a little bit harder to remember that, okay, D is the y coordinate of one of the points and A is the x coordinate of one of the other points. If we just label them using subscripts, then it's clear that x1 is the x coordinate of point number 1, and y2 is the y coordinate of point number 2. So we're just numbering our x's and numbering our y's. That's all that is. Okay, so that said, we're ready to write down our formula for slope. Tradition has it that the letter used to represent slope is an M. And it's, as I said, defined by a division. In the numerator, we'll have the difference of the y values. That will be y2 minus y1. And in the denominator, x2 minus x1. The change in y on top and the change in the x in the bottom. Okay, take the difference of the y's and divide by the difference of the x's. Some people refer to this as rise over run. I never especially like that because what if the line is going down? It's hard for me to think of a rise. And if you're running uphill, to me, the words just don't do it for me. But if rise over run works for you, then that's great. Vertical change divided by horizontal change. You will also occasionally see a little triangle symbol as abbreviation for change in. So you may see this written as a triangle and then a y, and then a triangle and then an x. This triangle is a Greek letter delta, and it's frequently used in math to represent change. And so you can think of this as a symbol for change in y divided by the change in x. And that is our formula that we use to calculate slope. So let's try it out. We want to find the slope of the line that joins the points 2, 3, and 5, 11. So let's see how that will look. The slope is y2 minus y1 divided by x2 minus x1. By the way, if you're ever trying to remember a formula, and you should remember this one, it's a good idea to write it out every time you use it for two reasons. One is if you have to write it out like 20 times when you're doing your homework assignment, you're going to remember it. And for two, it helps you remember to put the right things in the right places. That is, the y's on top, the x on the bottom, and so forth. Okay, so then y2 minus y1, 11 minus 3. And then we'll divide by 5 minus 2. Okay, changing y on top, changing x on the bottom. 11 minus 3 is 8. And then 5 minus 2 is 3. So the slope there is 8/3. Okay, and that's it. If you were wondering, how did I know that the second point was 511? Would it make a difference if I wrote down the points as 511 and 2, 3? What difference does it make? Well, it turns out that it doesn't make any difference, as we'll see right now. So it's the change in y divided by the change in x. So now let's say I subtract the other way. Okay, 3 minus 11 in the top, and then 2 minus 5 in the bottom. 3 minus 11 is negative 8. 2 minus 5 is negative 3. And then negative 8 divided by negative 3, still 8/3. You'll notice, of course, that we get the same answer regardless of which way we do the subtraction. So it doesn't matter. You do want to make sure that you're consistent about it. Some things that will be wrong would be if I did 11 minus 3 divided by 2 minus 5. Okay, not only do I get the wrong answer, we'll get negative 8/3, which is incorrect. What went wrong is I subtracted right to left for the y's, 11 minus 3, but then I went left to right on the x's. You have to be consistent. It doesn't matter which point is x1, y1, and which one is x2, y2, as long as you're consistent through the whole calculation. Also wrong, and this is probably a more common mistake, is to put the x's on top. So if you add 5 minus 2 divided by 11 minus 3, that will give you 3/8, and that is also wrong. Remember that it is the y change on the top, not the x change. Change in y divided by the change in x. If you write the formula every time you use it, you're less likely to make that mistake, which is a good thing. Okay, so more examples. Okay, next, we want to find the slope of the line that joins 6, negative 3, and 4, 9. So m for slope, that is y2 minus y1 divided by x2 minus x1. Okay, and it's up to you which point you consider to be the first point and which point you consider to be the second point. So I'm going to go right to left. I'm just used to it. So let's say 9 minus negative 3. You've got to be careful with double negatives. And then 4 minus 6. 9 minus negative 3 is 12. And then 4 minus 6 is negative 2. Okay, 12 divided by negative 2 is negative 6. Okay, so the slope there is negative 6. Okay, let's try this again. Maybe pause the video, try this calculation yourself, and then restart the video and see how you did. Okay, so once again, we're given a pair of points and we would like to calculate the slope between the two. So let's say that m is our change in y divided by change in x. That's also known as y2 minus y1 divided by x2 minus x1. Okay, this time I'm going to go left to right just because I feel like it. 1 minus negative 8 in the top, those were both y's, and then 4 minus negative 3 in the bottom. Okay, 1 minus negative 8 is 9, and then 4 minus negative 3 is 7. So our slope is 9/7. Okay, in the next part, we want to take a look at horizontal and vertical lines and what the story is for their slopes. So taking a look first at this horizontal line, we have negative 4, 7 and 2, 7. If we make the calculation, we'll have y2 minus y1. Are you getting sick of this yet? X2 minus x1. Changing y, 7 minus 7. Change in x, 2 minus -4. We'll have 0 divided by 6, which is 0. Okay, you'll notice on this horizontal line that the change in y, the numerator on our fraction, ended up being 0. And we ended up with 0 for the slope. And that's consistent with what we saw at the beginning of the video, where a line with 0 slope should be horizontal. And so yes, we've got that. Okay, turns out that that's true for every horizontal line that's going to have a 0 slope. Okay, let's try the slope for this vertical line. Okay, so change in y's first. We'll have 8 minus -1. Down below, we'll have 3 minus 3. 8 minus -1 is 9, and then 3 minus 3 is 0. 9 divided by 0 is undefined. The slope is undefined, so we just need to write that. There's no number we're going to get for an answer. If you're using some sort of online homework to do questions like this, then you may have a multiple choice where one of which is undefined. You might also write D and E for does not exist for the slope when it's a vertical line. Every vertical line has undefined slope. Every horizontal line has a 0 slope. Okay. We want to find the slope of the line that passes through -5, 6 and 2, 6. So here, change in y over change in x, I can see that I have 6 minus 6 in the top, and then -5 minus 2 in the bottom. That's 0 over I don't care what, and that's going to be 0. Or I should make that a 7. Okay, -7. All right, so here it's 0. Okay, our line was horizontal. That is 0 slope. All right, so you're probably going to guess that this one is going to be vertical, and you're going to be right. We'll have y2 minus y1 over x2 minus x1, and that's our slope. So change in y is -11 minus 6 in the top, and 4 minus 4 in the bottom. That gives us -17 over 0, and that is undefined. Okay, all right. So this takes us to the end of our video on slope. Just the quick summary. To calculate slope, which is a measure of how steep a line is, you take the change in the y direction divided by the change in the x direction. And the bigger the number you get, the steeper the line is. If you get an undefined answer, it's a vertical line. If you get 0, it is a horizontal line. It doesn't matter what order you subtract the points in, that is x1, y1, or x2, y2. It doesn't matter which point is which, as long as you're consistent about the order you do the subtraction in and the y's go on top. Okay, that's it. Let me know if you have any questions, and then have a great day.